Hi everyone, today we are going to code the graph coloring problem in C. So first of all we include this standard input output file. Then we have this function color. So the color will actually color the graph in all possible color combinations. So we'll come here later. Then we have the chromatic function. So the chromatic function will return the chromatic number of the graph. So we'll do this also, and currently we have to start from the main function. So in the main function, first we have to initialize n, which is the number of vertices, then I and j are the index, then c num. So this will be holding the chromatic number, and then we have to in another variable we need, that is a. So I'll come to this a later. So first we have to print something to the user. So enter the number of vertices in the graph. So user will enter this, so we have to scan %d. After this we have to initialize the adjacency matrix array, so which will be int type 10 and 10. Then we have to initialize a color row which will be of size n, and it will actually hold the color of the particular vertices. Then we have to print and ask the user for adjacency matrix. After this we have to scan the full matrix, so this is the same thing for scanning a 2D array. I is equal to 0. So scan. So the scanning is done, and now the chromatic function will return the chromatic number. So cnum is equal to chromatic adjacency matrix, and we have to pass this total number of vertex. So these are the two parameters we need to pass to this function. After this we'll print something to the user, that is the chromatic number we have to print. So graph is %d, so it will be something cnum chromatic number. Then we have to print all the possible color combinations. So print possible color combinations are. So after that we have to print this vertex, and we have to print the vertex, and below it will be the or color combinations. So first we print this one. So finally you have to call the color method, the color function, sorry. We have to pass this a, so the a actually denotes the vertex of the particular graph. So when a is 0, it means the first vertex. So as a will be increasing, so the vertex number will actually be increasing. So the a is 0 means first vertex, a is 1 means second vertex. So a is basically referring the vertex of the graph, the particular vertex that is currently being considered. So color vertex a, we have the c num, that is the chromatic number, and then we have to pass the color row. The color row will actually be coloring the color row is the array where we have to basically save the color of the particular vertex. Then we pass the adjacency matrix, and then finally so these are all the things that we have to pass in this function. So our main method is over. So now we move to this chromatic function. So in this chromatic function, we first, so we see that in the chromatic function we pass this adj and n. So this adj is there and this n is there. So first we have to initialize something. So int max will basically hold the current chromatic value till the graph is being so max basically will hold the chromatic number, and finally max will be the chromatic number of the graph. So we'll see that how. So first max, then new call. So new call is the particular variable which will hold that whether we have to introduce a new color or the current color is enough. So new color, we see that in a while. ij, then we have another what is called color row. So the color row will actually be holding the color of the particular vertex, any particular vertex. So that's all we need. After that, so color row, so first color the first vertex. So first vertex is colored with 1. So first vertex is colored with vertex 1, with color 1. Then we have, so the current maximum chromatic number is max is set to 1, and new curl is set to 0. Now so we'll color from starting from, so first vertex, 0th vertex is already colored. So now we have this first vertex and up till the nth vertex, n minus 1th. So we'll check adjacency with the already colored vertex. So the j will run from 0 to I. So j 0, j less than I. Now Now we'll check for adjacency. So if we check that, if uh, adjacency is there, that is ij is adjacent, so if it is adjacent, so we can't do anything, so new curl should be 1, so we have to introduce a new color. So new curl should be 1, else uh, else if it is not adjacent, then so we can color the current vertex with the same color that of I. So color row of the current vertex, that is sorry I, we can color the same that is of j. So color row of j. So basically if this tells that if we are coloring this, we cannot color, that is the adjacency is not there. So if I is not adjacent to j, so we can color the I with that same color of j. So okay, so now we have to put the new color as 0 because we have not used any new color, and we have to break. So we breaking from this loop because the current I is already colored. So basically our target is coloring I. So when we see that the I is colored, we just break from this loop. Now in the outer loop we check if new curl equals to 1. So if new curl equals to 1, it means that everything is just adjacent. So up till now we cannot color I with any of the previous colors, so we have to introduce a new color. So here we can color it with a new color. So color, so first we have to increase the max. So max is not the previous one. Now our chromatic number has increased, so max will be max plus 1, and just color this I, color row I equals to max. So now we have colored it perfectly. So after that our main loop is ended, and then we have to return max. So max will be the final chromatic number of the graph. Okay, so max will be returned over here, so that will be a chromatic number. So after that we call this color. So this is the color. Okay, so first we check a condition. No, first we have to include this. So there is a, then we have this cnum, row, color row, adjacency matrix, then finally the n. So these are the arguments that we require. So first we'll check if a less than n or not. If a is greater than n, then it implies that all the vertices are colored. So we'll just return from that case. So here we are talking about the different case, that is vertices are still remaining to be colored. So a is less than n over here. So first we have to initialize I and j. In this case I is different, so I is the current, so I is the current color that we have chosen. Okay, so for I is equal to 0, so let it be 1. So I starting from 1, so, and I less than equal to max. So obviously it will be less than or equal to max, because this not CNum. So it will always be less than or equal to max, because max is the chromatic number. So what essentially we are going to do over here is that we'll color a particular we will color a particular vertex, and then we will just do a recursive call of the same, and just will increase the vertex number by 1, and it will color the second vertex, and like that we will constantly keep on doing till all the vertices are colored. So till max. So I is holding over here the chromatic, the particular color that is currently it is stored in I. So we'll include one thing here, that is restricted. So restricted basically checks if a particular color is restricted to a given vertex or not. So, and we'll also include a temporary array for storing the previous values before calling uh, a recursive call. So restricted equals 0. Now we'll choose a particular vertex one by one. So we'll go for this. No, so the a particular vertex one by one we will choose by j. So j equals to 0 and j less than, it will be a, because our current vertex is a. So our goal is to color this vertex a. So j will be going from the 0th vertex to the a minus 1th vertex, and there will be a j plus plus. Okay, now we'll check adjacency of a and j. So if a is adjacent to j, that is, this is 1, and if color row, the color row of j equal to I. So we are seeing that if j is adjacent to a and the color of j is I, so obviously we cannot color a with I. So in that case we have to restrict. So we have to just restrict this, so the restricted variable will be 1. So now we can understand the why we have introduced this restricted. So whenever we cannot color with I, so we can just do this restricted to 1. We can also do this by true or false, but 0 1 is more convenient. Okay, then we have to break. So we have nothing else to do, we can't color with I, so now we have to increase I or something like that. But if it is not the case, so if it is not the case, it will be restricted will be 0. Restricted will be 0. So restricted will be 0 in that case. Okay, now we are coming back to this loop. So if the restricted is 0, if this restricted is 0, uh, what we'll do is that 0, what we'll do is that we simply color that particular a with I, the ith color. So it says that it is not restricted, so we can easily do this coloring, so there will not be any problem as such. So it will be very easy to be colored, and after that we'll call the same function a plus 1. So we are moving to the next vertex, so a plus 1. Then we have the max, that is the chromatic number, and the color row that we have created just now. Then we have the adj and n. So these are the things. So we are calling the same function, and it will color a plus 1 the similar way we have colored a. So but before doing this, we have to store the particular color row in a temporary variable that we have created, this temp in. So no overlapping of variables and values arrives. So to ensure that, we have to store this thing. So temp of j equals to color row of j. So we have stored this, and after that we have to retrieve the value. So after the function call has ended, so after the ending of the recursive call, we have to retrieve the value. So j equals 0, and color row will take all the values that are there in temp. So that's done for this part. And now, so whenever this function is, the call part is empty, so it has been called, then we have to just return from the function, return. And then let's come to the else part. So the else part means that we have already completed a particular variation. So whenever we have completed a particular variation, we have to print that particular variation. So printing this part is quite simple. So we have to just int I, then printf, then we have to do the color row to color, and then we have to just print this color row array. So that's all. We have to just print this. %d color row I. So we have to print this, and we have to print the next line. So there's the next line, and then we have to return. So hopefully this will do. Looks perfect. So let's just build this. So the build is complete, and looks like the compilation has been done, and there is no error as such. Okay, now we have to run this program. So just open the terminal, this command prompt, and so the program is graphcall.c, the executable graphcall. So now it is asking for the number of vertices in the graph. So I have made one example over here. So this will be the demo input, and we'll see how the graph is being colored. So there are 5 vertices, so I have to put the adjacency matrix now. So it will be 0 1 1 0 1 0 1 1 1 0 1 0 1 0 1 0 1 0 1 0 1 0. So this that. Okay, so the vertex is not being colored properly. It seems like the chromatic number is perfectly fine. Let me check this once more. 1 1 0 1 0 1 0 1 0 1 0 1 0 1 0. Okay, so we have some problem regarding the color function. The chromatic number is quite fine, so the color function we have to check it once more. So let's just check this function. What have we done wrong? If a less than n, into j restricted temp. Okay, so I equals 1 to I less than max, restricted is 0. Then we do j till 0 to a, then color row j is I, and this is just the adjacency checking. This is the color matching, restricted is 1. Okay, so else break else, restricted is 0, and if restricted equals okay, so it will be double equal to, so then we have this thing done, and this color is okay, and everything is okay over here, and other things, this part is okay. I have seen this. Now let us rebuild this one. So it is compiled, and now we can do a rerun of this program. So it is 5, and just check this again. 0 1 1 1 0. So we see that now our program is running fine, and it has printed the cnum correctly. And so this is vertex 0 1 2 3 4. So the vertex is named 0 1 2 3 4. So in this example we have 1 to 5. So but in this programming, this running, we have 0 to 4, so that will be not a problem. And the color is like this, and there are total 12 type of different combinations that we see. So that's how we do this program, the graph coloring in C. So it's quite simple, just we have to remember the logic, the main logic behind this thing, that is this part. So else it is quite easy. We have to just do a recursive call and just return from the function, and just print whenever all the vertices are colored. So that's all for this video. Thank you for watching.